So, you are welcome to experimental physics 3. Earlier I have discussed about the experimental physics 1 and experimental physics 2. So, in experimental physics 3 mainly I will demonstrate experiments on solid state physics and modern physics, where some experiments on atomic physics, some experiments on quantum physics, some experiment on molecular physics. So, this I will discuss in this module 3. So, today in this first lecture I would like to tell you about the basic tools and instruments in laboratory, basically for solid state laboratory and this modern optics laboratory. What are the common instruments, what are the common tools we use for performing the experiment, that I will discuss, but I will not, it is not possible to cover in one class. So, few lectures I need to cover them. So, in laboratory when you will go, so you basic one instrument is, that is cathode ray oscilloscope, CRO. So, here you can see this CRO, all of you are quite familiar with this instrument. So, today I will discuss about the function of different knobs on front panel of the CRO, that I would like to tell you about this function of the different knobs, and then also what is the use of this CRO. There are many purpose for using the CRO in laboratory, but I will mention few of them what I generally use in research laboratory as well as in teaching laboratory, but it is not the only the use of this CRO is not limited in this few application, but there are many others applications. Then I will discuss other basic instruments in laboratory, that is how to produce magnetic field in laboratory, how to produce electric field in laboratory, how to measure magnetic field, how to measure electric field, how to measure the temperature, because the experiments we will perform in the laboratory in this experimental physics 3, there we will study some property of material as a function of temperature, as a function of magnetic field, as a function of electric field. Okay. So, there when we will discuss about the experiment, if beforehand we know about the basic requirement for those experiments, like magnetic field, electric field, temperature, then this CRO, cathode ray tube, and another very important instrument, basic instruments in laboratory is there, that is lock-in amplifier. You are quite familiar with the amplifier. So, we used to amplify the signal, but lock-in amplifier, there is very important instruments in laboratory to detect the very weak signal from the noise. Your signal is very weak, even it is weaker than the noise. So, how to extract that signal from the noise accurately? So, for that purpose we use lock-in amplifier. So, I will discuss about the lock-in amplifier also. So, I need few classes, few lectures to cover all these things. So, today let us concentrate to discuss about the cathode ray oscilloscope. This is very common instrument, you have seen, you have used also, you may know everything, okay. But let me just remind you the use of different knobs of the oscilloscope, so that you confidently you can use in laboratory. So this so here let me just switch on the so what are the knobs? One first, this is the power on and off red button. So let me push this one. So now it is showing this power is on, and here on the screen, this is the this actually in experimental physics 1 I have discussed about the CRT, okay. What are the internal component of the CRO I have discussed. So today actually I will not discuss about that much. Today I will concentrate myself to how to use the front panel of the CRO for different application. So that I would like to tell you. So here on the screen you are seeing a line, So this basically this from CRT, from cathode ray tube, the electron beams are coming and falling on the screen. So here this electron beam now falling on the screen. So where it is falling, that place is a phosphorus screen. So there will be illumination on that point. So here you are seeing line means electrons is falling on along this line. So basically here this X deflection and Y deflection, two sets of deflecting plates are there. So that deflecting plate basically here for X and for Y. So here you can see this X position. If I just move this one, so I can change the X position of the X position of the electrons falling on the screen, okay. So when I am rotating this knob means I am changing the voltage to the deflecting plate, X plate, okay. These are basically capacitor plate, two plate, okay. So voltage is applied, now electric field is produced. So this electron beam is passing through this between these two plates. When it is passing, then there will be force on this electrons due to the electric field. So that electric field I can change, and this then force will change and it will move it will shift depending on the direction of the field. So here basically I am changing the voltage of the deflecting plate, right. Similarly Y position, okay. So here basically the Y plate, the deflection plate, their voltage I am changing this. So for X plate and Y plate, X position, Y position, okay, that we can change using this, okay. So here let me, this is the intensity knob, okay, this is the focusing knob. Here I am seeing this X magnitude, okay. So below is multiplied with 10. So this, let me tell one after another. So intensity you can just depending on your requirement, just you can change the intensity here. So you are changing the intensity, just rotating knob, what you are doing. So internally this this intensity is increase or decrease, means either number of electrons are coming, I think number of electrons are coming on the screen, that is more, then intensity will be higher, is less, it will be lower. So, here somewhere you are changing the voltage, I think grid voltage or the some pre-acceleration voltage, there you are increasing or decreasing. So, thus you are controlling the number of electrons falling on the screen. That also it can be attached, I do not know exactly, but it can be also one can control the filament current. Okay. So, things is that number of electrons should be higher when we want higher intensity and vice versa. Okay. So, this is the intensity knob. So, when you are rotating this one, what is happening inside, that also I think you should understand, because I have discussed about the internal component. So, externally this knob basically we use for changing the intensity of the beam. Now, if this beam is, we can focus it, you see, now is we can make it very sharp. Okay. So, focusing knob, so there these basically lens are there, electrostatic lenses are there in the tube. So, that we are from this, using this knob basically we are changing the voltage, we are changing the electric field in that circuit, electrostatic lens, in that circuit we are changing the some voltage or corresponding electric field. Okay. So, this is the intensity knob, okay, focusing knob. This another knob. So, there are, you see, in this CRO there are some knobs, but in other CRO that knobs are not there, different type knobs are there. Okay. So, but main knobs are, let me discuss just main knobs and use of them. Okay. Here some magnification etc. it is there, but in other oscilloscope this knob is not there. Okay. What is the function of that I can tell, but let not discuss about the uncommon of knobs right now, then we will be deviated from our main aim. So, here so CRO, the use of CRO first, you see this, we can measure the voltage as well as even current also we can measure, voltage, current and the frequency of a AC signal. If it is DC signal, we can measure the voltage, corresponding current also one can measure. Okay. Current, voltage and frequency, mainly these three we can measure using the CRO for any signal. So, I have a signal generator, okay. So, I can, this the generator, it can generate, is a tail function generator. Okay. So, I can generate different signal, this of sine function, of different functions basically. So, this it can be sinusoidal signal, it can be sawtooth signal, it can be square waves. Okay. So, different kind of signal we can generate from this generator, and also we can get different amplitude as well as different frequency of that signal. So, here is showing that 5 kilohertz and 5 volt, peak to peak 5 volt, okay, and DC part here 0, and this is the sinusoidal signal. So, here options are there, you can get other signal also, as I told, sawtooth, triangular signal, triangular, square. Okay. So, let us not discuss about the signal generator. I need a signal. So, I am taking a signal. Now, I want to measure the voltage, time period or the frequency of the signal, etc. Okay. So, CRO I have to use for that purpose, or we use for that purpose. Okay. So, here you are seeing this signal is coming and I put in this channel, it is a channel 1, it is a dual beam oscilloscope. So, it has two channels, channel 1 and channel 2. Okay. So, as I told this, I can measure the voltage, peak to peak voltage of the signal, as well as I can measure the frequency of the signal. So, here as I told x and y, so this is the x axis and this is the y axis. So, here this voltage is varying along the y axis, right. Along the y axis voltage is varying of the signal, amplitude, voltage in amplitude, basically amplitude in volt. So, that I should be able to measure using the oscilloscope, means this along the y direction, the divisions you are seeing, that is the basically that scale is in volt. Okay. So, now that scale along the y axis, that scale I can change that scale. Okay. So, for that this is the knob. Here this whatever the reading is written, you can see this is here it is written V volt, I think this V volt, 20, 10, 5, 2, 1, okay, 0.5, 0.2, 0.3, okay. Then this here now 50, it is in millivolt, okay. So, these are 50 millivolt, 20 millivolt, 10 millivolt, okay, 5 millivolt. Okay. So, you can choose the scale changing this knob. Okay. So, I have put here at 1. So, what does it mean? So, here this bigger division you are seeing, that is each division is basically 1 volt. So, now in your signal peak to peak value, how much, what is the value that you want to find out. So, just let me take as okay, coincide the yes, this their peak at this this horizontal line, along this horizontal line. So, 1, 2, 3, 4. 1, 2, 3, 4 and this is more or less 0.5. So, this peak to peak volt here it is showing it is a 4.5 volt. Why? Here I have kept it at 1 volt per division. Okay. So, I will tell this the signal is having the peak to peak amplitude, that is 4.5 volt, but this signal generator it is telling this is peak to peak 5 volt, but my CRO it is giving me value that 4.5 volt. So, for unknown signal, if I want to measure the amplitude, it will give, so that reading will be wrong. So, here I came to know that reading is wrong, because either this function generator is wrong or there is something wrong in the CRO. There it is telling it is 5 volt peak to peak value, but my CRO, my measurement is telling it is 4.5 volt. So, it should not be the case, because yeah, it may not be exactly same, but there will be error, but it cannot be that much different. Okay. So, that is why that here this options is there, you know, this cal. So, here you can calibrate, here it is a written cal, okay. From here you can take, so it is giving 0.2 volt, it is giving 0.2 volt, and this below one is giving 2 volt, 2 volt this I think the squared signal, okay, is the squared signal of 0.2 volt and 2 volt, okay. So, my CRO first one should calibrate, taking that signal from here, put as an input to the CRO, you check it, okay, whether calibration is correct or not. So, actually there is a calibration knob here, you know, I do not know this calibration knob, generally calibration knob, if you turned maximum to the left, you see it is changing. When I am rotating this one, but it is 1 volt, it is 1 volt per division, but when I am changing this one, it is a changing, but my signal is of 5 volt. So, calibration is not is in correct way. So, I think what happens, this should be here, I do not know exactly, it may be the case, let me make it 5. Okay. Let me make it 5 and then I will tell you, sometimes I have to, I am, let me check, this is 1, it is a slightly, I have to reduce slightly, I think this is the case. Slightly more. Yes, now I can see 1, 2, 3, 4, 5 division. Okay. So, it is the one it's the this knob is at 1 volt per division in that scale. So, so if I keep it here, then it is giving me the correct value. So, this is basically 2.5 division. So, this 5 volt is the 1 division, more or less it is the 1, slightly more. So, this knob, if I rotate, if I change, the calibration changes. So, now generally tell if it is complete, if you rotate at the towards the left and just it's making one noise, just means it got stuck there. So, then generally it tells that it's now it's the calibrated one. Okay. If it is calibrated one in this condition, but then it should be I think 1, 2, 3, 4, 4.5 again it is showing 4.5 volt peak to peak 1, 2, 3, 4, 4.5 or slightly more. But so let me take another voltage here. I think just I will change the voltage here, signal, this is the amplitude. Now I am taking different amplitude, say 6 or 8, it is now 8, okay, 8. So, for 8 you see where 1, 2, 3, 4, 5, 6, 7, now it is coming 7.5. So, I think this 0.5 some offset something is there. Okay. So, better whether this is correct or that other one is correct, that I am not sure. So, that is why generally we should do calibration using this, we should check the calibration. So, you remove it, and if I take 2 volt from as a signal from here and I put signal here, okay. You see, as I told that you will get the square wave. So, here it should be 2 volt. Let me check whether it is 2 volt. You see, it is 1, 2, yes, more or less it is 2 volt. Okay, it is 2 volt 2 division. So, it is at, if I 0.5, so it should be in 4th division 1, 2, 3, 4, yeah, more or less I think it is so it is a slightly, it is not giving. So, there is some problem with this one. I think it should be, its calibration knob is not working properly. So, it should be 1, 2, 3, 4. Now, I will put here, then this, yes. Now, this, it is now 4th division. I have put 0.5 this per division. So, it is 4, it is 2 volt. So, this my signal here. So, now it is calibrated one. Okay. So, now I think I will stop next class. Okay. So, thank you.